Can you hear me, all of you? Switch on the camera. One, two, three, four, 12 people. Okay. अरे हमारा लीडर ही एब्सेंट है. आदित्य, श्रद्धा, both are absent.
Hello, sir. Am I present, sir?
Aditya is present, correct. Anyway, so two things. Let me talk to you or discuss before we go to the subject PPT. Please, your performance in the note that your performance in the mid semester was terrible. Particularly question number 2, I don't know, nobody has attempted except Sudhakar. कौन है Sudhakar? Divakar. Karanam. So he is also absent. Except one student, all others, they have not attempted the impulse response function question, that is question number 2. I don't know why. Okay. And in question, I will talk about that some other day. In last question, also you have made a lot of mistake. First question also you have made a mistake. 20%, why you have taken 0.83? 20% gap means 1 plus minus 0.2. So one of the natural frequency will be 0.8 into omega n. Another natural frequency will be 1.2 into omega n. But most of you have somehow ended up 0.83. I don't know why. Okay, so that was a mistake. Second, most of you have directly got the mass ratio without line by line derivation. So I'll discuss that, but I wanted to tell you that your performance has not been good. I think, have I given you the list of marks? नहीं दिया. If you want before Holi, I can give it. I can give it today only. It is not interesting. Except one, highest is 15. Except one student, highest is 15. I don't know why. Okay, 15 or 16 maybe. I don't know why. So performance has been bad. So again, you go through your question paper and whatever you have answered and try to find out why you are unable to answer the questions correctly. At least you cannot raise that there was time shortage because questions are easy and 1 hour. That is number one thing I wanted to discuss with you. Second is, our online class will be till 21st of March. That is, our next Tuesday class will be in the classroom. Just now I had another class and I have taken that class in the classroom. That is final year subject. So students, final year students, they have reported and classroom teaching has begun in the department. So there is no reason why you cannot come to the campus. So 21st of March, that is next Tuesday, vibration lecture will happen in the classroom. If you come to the classroom, you can attend. There will not be any online transmission. If you don't come to the classroom, you miss it. Simple. ठीक है. सो यू मेक इट ए पॉइंट, अभी भी 7-8 दिन है, कौन सा ट्रेन बुक करना है, क्या करना है, नहीं करना है, दैट यू फाइंड आउट. So if you don't come to the classroom, there will not be any online transmission for vibration lectures from next Tuesday, because college has already opened and allowed you to come to the campus. So since college has already allowed, you are expected to be in the campus. Final year students, they have come. So these are the 2 points. Let me go to the discussion of today's menu. That is, let me start the discussion with the problem that we have taken before mid-semester examination, multi-degree of freedom system. Okay, and if you look at your class note, you will see that this was our stiffness matrix and this was mass matrix. Fine. We found out fundamental natural frequency by finding K inverse M. So we did our matrix iteration with K inverse M, and matrix iteration gave us fundamental natural frequency. You remember, you have done it. Now, today, suppose what will happen if we do the matrix iteration with M inverse K? Do it. I'll give you 5 minutes only. Problem is same problem. So mass matrix remains same as you see on the screen. Stiffness matrix remains same. Definitely M inverse K. So you follow the same procedure. लेकिन हमारा इटरेशन का इक्वेशन क्या होगा, वो संभाल के लिखो. इटरेशन का इक्वेशन क्या होगा? हाँ, I mean, it's not that easy. You have to see, this was the equation. Last time this was the equation. Omega square K inverse M into X is equal to X. So that was the matrix iteration equation for previous case. क्योंकि in the previous case, we took K inverse M. If we take M inverse K, तो omega square इधर आएगा. So our equation will be M inverse K into X is equal to omega square into X. Remember that. Okay. So our equation for matrix iteration for M inverse K will be M inverse K into X is equal to omega square into X. You have to derive that. If you derive that, automatically it will come. And now you find out what is M inverse K. It is easy. M inverse K is very, very easy. And start your iteration. M inverse K कितना आएगा बताओ मुझे. So you do the same matrix iteration, but with M inverse K, not K inverse M.
Sir, is it supposed to start moving towards the third mode shape?
हाँ बोलो बोलो क्या हुआ?
So is the matrix supposed to move towards third mode shape?
Not supposed to, it has to.
Oh, all right.
It has to, not supposed to. So it is ending up at the third natural frequency. कितना मिल रहा third natural frequency? 2 into square root k by m. Your iteration will finally end up at omega is equal to omega square will end up at 4 into k by m, or omega will end up at 2 into square root k by m. Other students, I will give little more time. Carry on the matrix iteration. It will not take many iteration, fortunately. In many other case, it may take many iteration, but in this case, it will not take many iteration. Hardly 4 iteration, you will get the convergence. M inverse K. Do it. I'll give you another 2-3 minutes. बाकी लोग इतना टाइम क्यों ले रहा बोलो?
Our answer is coming 1 minus 1 1.
Yeah, that is mode shape. 1 minus 1 1 is mode shape, and natural frequency is 2 into square root k by m, which is actually third or highest mode shape. So you can write down. If we do matrix iteration with m inverse k, it will always converge to highest natural frequency and mode shape. Highest eigenvalue and mode shape, or highest natural frequency and mode shape. This sentence is important. If we do carry out matrix iteration with m inverse k, iteration will always converge to highest natural frequency and mode shape. We will give a proof later on, not right now, but this has to happen. There is no other way. Now, having said this, you will agree that m inverse k is better than k inverse m. But even then, we don't like m inverse k because the matrix iteration converges to highest natural frequency. Who is more important, lowest natural frequency or highest natural frequency? Definitely lowest natural frequency is more important. So we have to always begin our matrix iteration with k inverse m. Although m inverse k is easier, but as an engineer, we have to begin with K inverse K. And now I will discuss a practical example where K inverse M is not that difficult. Okay. So let me take an example where K inverse M is much easy. Okay. So can you see it? Now K inverse matrix can directly be obtained in some examples. We will discuss that particular type of example where we can obtain flexibility matrix directly, and flexibility matrix, which is represented by chota a, small a, it is nothing but inverse of stiffness matrix K. Fine. It is defined, each coefficient in the flexibility matrix is defined by as Aij is called influence coefficient. It is defined as displacement at I due to unit force at J. इसको लिखो, दोनों लाइन लिखो. Flexibility matrix is inverse of stiffness matrix. It is represented by small a matrix where Aij is called influence coefficient, and it is defined as displacement at I due to unit force at J. This is slightly confusing. What we mean displacement at I due to unit force at J. But have you written it? Flexibility matrix is equal to K inverse, इसको लिखो और Aij का definition लिखो. And then I will show you an example where influence coefficient हम easily निकाल सकते हैं. So let me take the example of 3-disc rotor. So पहले समझने का कोशिश करो. This is an example where I have 3 rotating discs on a shaft, and the rotor is rotating at some RPM omega. This omega RPM should not come close to natural frequency. How many natural frequencies will be there? 3, because there are 3 discs. So there will be 3 natural frequencies, and running RPM should not come close to any of those 3 natural frequencies. So it is very important. However, running RPM generally, more often, it comes close to lowest natural frequency. So we need to know lowest natural frequency first, then of course other natural frequency. So how to find out lowest natural frequency? We have to go to K inverse N. Now in this case, there is no spring visible. So we cannot construct stiffness matrix. There is no spring visible. Agreed. But does it mean there is no stiffness present? There is stiffness present, but the springs are not visible. So what do? We go to the flexibility matrix and look at the definition of flexibility matrix. Displacement at I due to unit force at J. So suppose this is my I and this is J. What I will do? I will apply unit force at the center. Due to application of unit force at the center, the whole rotor will bend and there will be some deflection here. If I can find out the deflection here, that will give me Aij. Let me repeat again. What is Aij? Deflection at I due to unit force at J. So if I apply unit force at number 2 and measure deflection at number 1, it will give me A12. Deflection at I due to unit force at J will give me Aij. So if I measure deflection at coordinate number 1 due to unit force at coordinate number 2, whatever deflection I will get here, it will give me A12. Similarly, if I apply unit force here and measure the deflection here, it will give me A11. So This is how I can find out each value A11, A12. Okay? Now, from solid mechanics, we know the deflection formula. If it is simply supported, can you tell me what will be A22? Batao. Solid mechanics. You already know what will, if the bearings are assumed to be simply support, what will be A22? That is, what is the deflection at coordinate number 2 due to a unit force at the same location, A22. Kitna hoga? From solid mechanics. You know it. All of you know it.
Sir, L cube by 48 EI.
Correct. L cube by 48 EI. Other flexibility coefficient you may not know, but if you look at your design data book, it has given you the formula to calculate other influence coefficient. Okay, so these are the values. Write down. From this we obtain from design data book. A11 is equal to A33. A11 is equal to A33. From design data book formula, we get it 3L cube by 256 EI. Similarly, A12 is equal to A21. This is called reciprocity theorem. Aij has to be equal to Aji. That is called Beatty-Maxwell reciprocity theorem, a very important theorem in solid mechanics. Aij is equal to Aji. Deflection at I due to unit force at J will be equal to deflection at J due to unit force at I. This is known as Beatty-Maxwell reciprocity theorem in solid mechanics. So A12 will be equal to A21. It will be again A23 will be equal to A32. अब A21 और A23 क्यों बराबर है? Because number 1 and number 3 they are, see, L by 4, this is also L by 4. So number 1 and number 3 they are symmetric. इसीलिए A23, A21 is equal to A23. So this is 11L cube by 768 EI. A13 is equal to A31, 7L cube by 768 EI. And finally, this is my influence coefficient matrix. And this is my mass matrix. ठीक है, पूरा लिखो. पूरा लिखो. Influence coefficient matrix and then mass matrix. And now influence coefficient matrix is already K inverse. So our matrix iteration can begin with influence coefficient matrix into mass matrix. So this is the advantage in this case, that influence coefficient matrix is already K inverse. So my matrix iteration should begin with influence coefficient multiplied by mass matrix. Fine. तो दोनों को multiply करो, influence coefficient multiplied by mass matrix, then begin the matrix iteration method. It will converge to lowest natural frequency, remember, because influence coefficient matrix is K inverse. So influence coefficient matrix multiplied by mass matrix, you will get something. Let me see what you are getting. influence coefficient matrix multiplied by mass matrix.
The second column element all becomes double and M.
No, I'm not
gets out.
asking you मैट्रिक्स इटरेशन का पहले प्रोडक्ट कितना आ रहा. So this is, you have to set up the iteration equation. So this is the iteration equation. K inverse M is equal to जो है, हाँ, you have to set up K inverse M का जगह A into M into X is 1 by omega n square into X. You have to set up this matrix iteration equation first. उसके बाद matrix equation चालू करना होगा. So this is the starting point of matrix iteration. You have to do it. You see, you should get this line. This is your beginning line of matrix iteration. ये लाना पड़ेगा. यहां से मैट्रिक्स इटरेशन चालू होगा. अभी मैट्रिक्स इटरेशन करो, 4-5 इटरेशन में आंसर आ जाएगा.
So,
You can start with 111 or anything else. No problem.
so the mode shape is 1, 1.42 and 1.
Correct. So let me see how I have got the result. I started with 111. So yes, I'm getting 1. So what is the natural frequency? That to find out.
So
What is
under
the
root
natural
1096.
frequency? That is important. And
Under
from this natural frequency, you can calculate critical speed because this natural frequency corresponds to critical speed. लेकिन पहले natural frequency निकालो.
So it's under root 1096.4 EI by ml cube.
मुझे ऐसा नहीं मिल रहा. ठीक से करो, ठीक से करो. अंडर रूट 16.2 कौन निकालेगा? हाँ? So final answer is 4.031 square root EI by ml cube. Okay. So if we know the diameter of the shaft, we can calculate I. Okay. I is pi by 64 d4. This is not polar moment of inertia. This is bending moment of inertia. Okay, pi by 64 into d4. Diameter of the shaft, we can calculate I. M is, of course, the mass of individual disc. So if we know mass of individual disc, diameter of the shaft, we can find out natural frequency. Now this natural frequency will correspond to critical speed. Fine. So how to find out critical speed? Radian per second will divide by 2 pi, it will become hertz, and then hertz multiplied by 60 will give us RPM or critical speed. So this is how critical speed of a multi-disc rotor can be found out, okay, using matrix iteration method. Fine. Now, any question you can ask me right now. We just solved a practical problem where we need to know the critical speed. We found it by matrix iteration method. K inverse we obtain from solid mechanics. K inverse is nothing but influence coefficient matrix. We obtain it from solid mechanics and we are getting it 1.421. Now, any question? Now, in this case, now please remember one thing. So far, we have only focused on lowest natural frequency. Although we can find out highest natural frequency in this case also. Fine. But generally, we don't give that much of importance to highest natural frequency. We give importance to lowest natural frequency, then next lowest. So after this, our focus should go to second natural frequency, not third natural frequency. So how to find out second natural frequency, we'll discuss in the next class. But this is also an important part, that how to find out lowest natural frequency. Now, these are different examples. I'll give you through the email I will send this PPT. You have to solve each problem. Lowest natural frequency. So how do you proceed? You first write down equations of motion and then construct mass matrix, which is diagonal. construct stiffness matrix, and then by matrix iteration method, that means K inverse M. In this case, K inverse mathematically you have to find out. Okay, in each case you have to first write down equation of motion, then construct mass matrix, construct K matrix, find out K inverse M, and then proceed matrix iteration method to calculate or to obtain lowest natural frequency. तो कितने प्रॉब्लम है? 1 2 3 4 5. This is by flexibility coefficient matrix, because this is sacked with 3 disc. इसमें फर्क क्या है? In our previous example, central disk mass was double. In this case, all the disk mass is same. Okay, so this is a problem you have to do. This problem you have to do. So a branch भी है. Branch को भी कैसे करेंगे? You have to write down equation of motion. If you can write down equation of motion, you can get mass matrix, you can get K matrix. इसमें equation motion संभाल के लिखना पड़ेगा. ठीक है? This is called branch system. Okay? चलो नहीं, orthogonality I will discuss next class. आज नहीं. There is a heavy mathematics into it. आज इतना ही. Anything you want to ask? बताओ. I have just discussed basically what we have discussed already before the exam. Our focus was how to calculate lowest natural frequency. So in the next class, we will take up mode orthogonality principle and how we can use mode orthogonality principle to calculate second natural frequency or third natural frequency. So little bit of mathematics is involved. वो करेंगे. हाँ. I'll be giving these sample problems exam practice के लिए. ये सब करके रखो. ठीक है? Any doubt? Your mid-sem exam performance wasn't good. My marks और sample answer दोनों ही भेज देंगे एक दिन में. Can we leave or you have some question? बोलो. We took 0.2 distance from single degree of freedom natural frequency. बोलो. Correct. So operating speed is omega n. Operating speed is omega n. And that is why resonance took place. See, we went for an absorber because resonance took place. And when the resonance took place, operating frequency by mistake exactly matched with omega n. तो 20% away from operating speed का indirectly meaning है 20% away from omega n. So one natural frequency will be 0.8 omega n, second natural frequency will be 1.2 omega n. One thing everybody missed, I mean that is bad. There will be two natural frequency. Which natural frequency we should focus? We should not focus on the higher natural frequency. क्यों? किसी ने उसको explain किया ही नहीं. क्यों? Nobody explained that. Because the distance of higher natural frequency from omega n is always greater than distance of lower natural frequency from omega n. So who is closer to omega n? It is the lower natural frequency. So if lower natural frequency is 20% away, definitely higher natural frequency is more than 20% away. But if higher natural frequency is 20% away, lower natural frequency may be 18% away or 16% away. So we should focus on lower natural frequency 20% away and not higher natural frequency 20% away. किसी ने इसको डिस्कस किया नहीं? You lost marks. I mean, most of you have answered in your own way. Out of 6, I have given 2. Let me tell you. Because this 0.8 and 1.2, you could not calculate correctly. And then you did not explain that you have to focus on the lower natural frequency. Okay. हाँ. और कुछ किसी को बोलना है? I'll give the sample solution also. Your performance is not really good. And one of the reason is that online teaching and online learning is inadequate. You have to get out of it as quickly as possible. ठीक है? फिर कल मिलेंगे. चलो, आज यहीं पे क्लास खत्म कर रहे हैं. You can leave now.